Hello, folks of geometry. Welcome to 3-3. And I know that I know that we talked a little bit about equilateral and isosceles already, but there's a couple different properties that you need to be familiar with when you're looking at isosceles and equilateral. So isosceles, of course, simply means that you have two sides that are congruent, and equilateral means that you have all sides congruent. Okay? That's just, you should know that. I mean, that information should be at your fingertips. So that's kind of what you're looking at there. So let's start with this. So an isosceles triangle means that you've got two congruent sides. Okay? So here's kind of what isosceles theorem says. If you have that situation, if you have two congruent sides, then their opposite angles are going to be equal. Okay? So if AC is congruent to BC, if I have two congruent sides, then their opposite angles are going to be equal. Okay, that's it. In an isosceles triangle, the angles going across, across from the congruent sides are equal. Okay, notice the situation. If I flip it around, if I can show for some reason that, hey, angle 1 is congruent to angle 2, then I can go across and say, yeah, DE is congruent to FE. Okay, that's what I can say. So in an isosceles triangle, if the two angles are congruent, the opposite sides are congruent. Likewise, if the two sides are congruent, the two angles are congruent. All right, so that's kind of the way I go. That's kind of the way. Basically, your angles and your sides have to go across. Okay, so here you are told, notice, P and M are congruent. So I can say, you know what, angle P is congruent to angle M. All right, that means that those two sides are congruent. So they're looking for PN, they're looking for this length right here. Well, if this is 11, this is also going to be 11. All right, so then if MN is 11, PN is also 11. All right, pretty straightforward idea. If you have an isosceles triangle, this is just kind of one of those properties that you want to play around with and you want to make sure you understand. So here, a little bit different look. So this one's 7, this one's 9, this one is 2z minus 15. So now be wary here because this says T and S are congruent. Okay, so angle S is congruent to angle T. So that means I'm going across and across. So that means I want 2z minus 15 equal to 9. Okay, so be very, very careful. Many students will try to tell me that, hey, 2z minus 15 is equal to 7 and solve it from there, and that's just a big no-no. All right, that's just the wrong side. You have to go across. So 2z minus 15 equals 9. So 2z equals 24. So in this situation, a little bit of algebra, add 15, divide by 2, and I get z to equal 12. And again, all this is based on these two angles are congruent, so I go across. All right, so an equilateral triangle. So an equilateral triangle, as we said before, all three sides are equal. All three angles are congruent. And one little side note on that is that if it's equilateral, it's equiangular. If it's equiangular, it's equilateral. So what does each angle have to be? Well, a triangle's got to be 180 degrees. Okay, all triangles have to equal 180 degrees. But what I know is I've got three angles that are all the same. That's an A. So 3A equals 180. So A is going to be equal to 60. So every single angle in an equilateral triangle, this is every equilateral triangle that you can come up with, the angle measure has to be 60. Has to be. So anytime you have an equilateral triangle, you can know every angle is going to be 60. So if I look, no, this is a unique one because this is actually an equilateral triangle disguised as an isosceles triangle. So now let me show you what I mean. So we know this one's 60. Okay, we know that angle Q is 60. We also know PQ and RQ are equal. Okay, so right now, this is at least an isosceles. PQ is equal to RQ. Okay, we know that for a fact. So now, if that's true, that means those opposite sides are equal. Or opposite angles are equal. Sorry, opposite angles are equal. So now, we know that both of these are going to be x. Well, just by doing some simple math, x plus 60 has to equal 180. But if I solve that, x is going to be 60. So wait a second. All three of these are now 60. So that means R is 60, P is 60. That means all three are 60. That means it's an equilateral. That means all three sides are going to be 5 centimeters. And that's my answer. That's it. All this is based on, hey, I know this is 60, but it's isosceles, so those two got to be equal. Those two have to be equal. Okay, so now, wow, take a look at this. Okay. So let's start here, okay? 6y plus 3, 8y minus 5. We both know, okay, we know that that's isosceles. We know those two are equal. So I can solve for y without too much craziness. That becomes 0. That becomes 0. Divide by 2, divide by 2. Y equals 4. All right? I don't like that. Give me a proper 4. So now this one, the angle kind of gets a little messy here because they tell you this one's 4x minus 8 and E is 4x minus 8, but these two sides are congruent. So that means that angle and that angle are equal. So that means that is also 4x minus 8. So all three of these angles are 4x minus 8. So to figure out x, I actually want to set that equal to 60. So now, I'm sorry, I just kind of go into algebra mode. 128 is 17. So I get 17 for an answer for x. Okay, so how did I know that? Well, they told me that that's 4x minus 8. They also told me this is 4x minus 8, this angle E here. But because those two sides are equal, I can go across. So if E is 4x minus 8, then D is as well. That's also going to be 4x minus 8. Okay, let's take a look here. All right, so again, check this out. This is 2x, this is 2x. Because these two are isosceles, I can go across. So that's 2x. So all three of these are equal. That means it's going to be an equilateral triangle. X is just going to be 30. My y then, because I know it's an equilateral triangle, I set each one there. So y should equal 2. All right, I've only figured that out once I figured out, hey, those are all equiangular. So that means it's equilateral. That means I can do this. All right, last piece. A little bit trickier. Well, x is a little bit trickier. Y is not too bad. Y, I just need to recognize those two are equal to each other. Right there. Bam. Bam. Okay, just set those two equal to each other, and off you go. So now, looking at the angles for x, okay, this is 6x plus 8. This is also 6x plus 8. I know this is 80. I know it's isosceles. So that means this plus this has got to equal 100. Where did I get the 100? All triangles have to equal 180. Okay, I know that that's 80, so I can subtract it. So I know these two angles have to add up to 100. So that means each one of these, because I can cut it in half, is going to be equal to 50. So I'm going to solve that. 6x is going to equal 7. There's my answer. And that's it. So 99% of this is in the setup. After that, it's just a couple of algebraic steps and you're done. But it's recognizing, are you dealing with a isosceles, equilateral, or one that looks like the other? What are you looking at, and how do I solve it? All right. So now you're working on 3-3 assignment. And your 3-3 quizzes. Sorry. And the next one will be your 3-1 through 3-3 review. I apologize for my horrible handwriting there. There you go. Okay.